Along with the equations of the line, equations of parallel and perpendicular lines is a very common topic, and I'm going to show you how this works. It's pretty simple. Alright, so here, first of all, look, I have two lines that are actually the same line, L1. For the sake of the illustration, let's say that this has a slope of M1. Alright, now first of all, I'm going to draw a line that is parallel to L1. And by parallel, we'll call this L2. By parallel, what we mean by definition is that they don't intersect. They don't touch each other. Okay, so you think about it. If they're running along together and you're considering the slope, how are their equations related? It's through the slope. Because here, a parallel line also has slope M1. Parallel lines have the same slope. Now secondly, we're going to look at perpendicular lines. Perpendicular lines are another special kind of line that is related to my original line in this way. It intersects the line, but not only just intersects it exactly head-on at a 90-degree angle. Alright, so in this way, our slope is the exact opposite. L2 has a slope that's the exact opposite, and this time they're not equal. My slope M2 is actually the negative reciprocal of the first line. So that means I take the first slope, I flip it upside down, make it a reciprocal, and then tack on a negative. Okay, so perpendicular lines have negative reciprocal slopes. Now I'm going to show you a couple of examples. First parallel, second perpendicular. If you understand the concepts of equations of lines, such as the standard form of the line, point-slope form of the line, slope-intercept form of the line, the slope, and x and y intercepts, this shouldn't be very difficult. Alright, so let's look at example 1. Alright, so here I want to find the equation of the line that passes through the point -1, 5 and is parallel to y minus 4x equals 7. Okay, so the first thing we need to do here is notice it says parallel. So I know that the slope of whatever my line is going to be the same as the slope of this line. But I don't know the slope of that line. Okay, so first let's figure out the slope. And the way I'm going to do this is by putting this line into slope-intercept form. So that means I solve for y, so I get y equals 4x plus 7, and there's our first clue. The slope is 4. The slope is 4 of this line, but since my line's parallel, they have the same slope. So since I have a point and a slope, I can use my point-slope form, which is y minus y1, slope times x minus x1, and I'm ready to go. I have y minus 5 equals 4x minus a negative 1. So that gives me y minus 5 equals 4x. Negative 1 is a plus 1, so it's going to be a plus 4. So y equals 4x plus 9. There's the equation of my line. And I'm saying that that's parallel to the first line, and it passes through this point. Okay? If you don't believe me, let me show you. I'm going to use Desmos.com, a great website, to illustrate how these two lines really are parallel. Let's take a look. Alright, so here we are on Desmos.com, and you can see here I have the point -1, 5 labeled, and I also have the line y minus 4x equals 7 drawn. Okay, so now I'm going to put in our line that I claim is parallel to this and passes through that point. We said that was y equals 4x plus 9. And there it is, look. Passes through the point, and I can zoom out as much as I want. Those two lines are never going to intersect each other. They have the same slope. Alright, so let's move on to an example that involves perpendicular lines. Now for example 2, I want to find the equation of the line passing through the point 2, 5, perpendicular to this equation, y plus x minus 3 times x minus y equals -9. And that's kind of mean because that's not in standard form or slope-intercept form. I've got to figure out what my slope is first of that line before I can go forward. Alright, so let's figure this out. The slope here, I have, well, let's just solve for y. So y plus x, then I have a negative 3x plus 3y, right? I got to distribute that negative 3 minus 9. Okay, so if I get all my x's on one side, I have 4y on the left. Let's see, plus x and a minus 3x becomes a negative 2x, and I add that over. So that's 2x minus 9. So then when I divide by 4, I get 2/4 x minus 9. And that tells me the slope, not of the line I want, but of this line. So I have a slope of 2/4, which is 1/2. So my slope, the slope I care about, since these lines are perpendicular, is the negative reciprocal of that. So that's going to be negative 2 over 1, or in other words, negative 2. That's the slope I want. Okay, now we're going to use slope-intercept form, and I just plug in my coordinates. I have a y minus 5 equals negative 2, x minus 2. Okay, so I get y minus 5 equals negative 2x plus 4. So that's going to be negative 2x, add the 5 over, plus 9. And there's the equation of my line, and I'm telling you this one is perpendicular to that one and passes through this point 25. And again, I'm going to use Desmos.com to illustrate this. Okay, so this time, look, I have a point 25 here, and I have that line that was in that weird form in this purple right here. Okay, so now I'm going to put in the line that we claim is perpendicular to this purple line and passes through the point. And we said that was y equals negative 2x plus 9. And there it is. Look, passes right through my point and is very much perpendicular to the purple line. Finding the equations of parallel and perpendicular lines is a very useful idea. It's not too difficult. You just need to know 2 rules on top of what you know about equations of lines. If you have any questions on this, please let me know. I'd be glad to help. And thanks for watching.